Hey everyone, welcome back to the Cyber Tutor channel. In today's episode of our Linux cybersecurity series, we're diving into one of the most important components of any operating system, the kernel. If you want to truly understand Linux security, you must understand how the kernel works, because the kernel controls everything. Let's break it down in a simple and cybersecurity-focused way. What is the kernel? The kernel is the core part of the operating system. Think of it as the brain of the system. It sits between applications, user programs, hardware, CPU, memory, disk, network cards. The kernel manages communication between them. Without the kernel, nothing works. How the Linux kernel works, simple mechanism. One process management. The kernel creates processes, schedules, CPU. Time terminates programs. It decides which program runs and when. Memory management. The kernel allocates RAM, protects memory regions, prevents programs from accessing other programs' memory. This isolation is critical for security. Device management. The kernel controls hard drives, network interfaces, USB devices, input/output systems. It uses drivers to communicate with hardware. System calls applications cannot directly access hardware. Instead, they use system calls, requests sent to the kernel. Example, opening a file, sending network data, creating a new process. The kernel validates and executes these requests. Kernel and security. The kernel is central to cybersecurity because privilege control. Linux uses privilege levels, user space, kernel space. Only trusted code runs in kernel space. Process isolation. The kernel prevents one process from interfering with another. Access control. The kernel enforces file permissions, user permissions, group permissions, security modules. Linux supports security frameworks like Linux App Armor. These enhance kernel-level security policies. Why kernel vulnerabilities are dangerous. If attackers exploit a kernel vulnerability, they can escalate privileges, gain root access, bypass security controls, install rootkits, control the entire system. Kernel exploits are extremely powerful. That's why patching is critical. Real-world impact. Many major attacks involve kernel vulnerabilities, including privilege escalation exploits, container breakout attacks, rootkits that hide malicious processes. Since Linux runs cloud servers, web servers, IoT devices, enterprise infrastructure. Kernel security directly affects global cybersecurity. Why cybersecurity students must understand the kernel. Understanding the kernel helps you analyze system behavior, detect rootkits, understand privilege escalation, secure Linux servers, prepare for red team and blue team roles. If you want to work in cloud security, SOC analysis, penetration testing, DevSecOps, kernel knowledge is foundational. The Linux kernel is the heart of the system and also one of the most critical layers in cybersecurity. Protecting the kernel means protecting everything above it. If this video helped you, don't forget to like, subscribe, and turn on notifications for more Linux cybersecurity content. Stay curious, stay secure. See you in the next video.